Hi guys, so welcome back to my channel. This is the first part of our mechanical engineering review regarding engineering mathematics and sciences. In this video, we are going to deal with unit conversion. This is problem set number 1. We have two primary sets of units, namely we have here English Engineering System or the USCS. This stands for United States Customary System. We also have here SI units or the International System units, also known as the metric system. Some examples of our English Engineering System, we have here mass, length, and time. For mass, in English units, we have pound mass. For length, we have foot. And for time, we have seconds. For SI, we have for mass, we have kilogram mass. For length, we have meter. And for time, we have second. So these are just few examples of those units. So basically, what we are going to do here is we are going to convert English units to SI units and vice versa. SI units to English units. It is expected that engineering problems are stated and solved using either these two units. So it is very important for us to know conversions or unit conversions. So let's proceed to our first sample problem. So for number 1, we have here, what is the temperature in degrees Celsius of absolute zero? First, we need to know the temperature at absolute zero in order for us to convert that to degrees Celsius. So when you say absolute zero, in thermodynamics, that is absolute zero temperature, that is equal to 0 Kelvin. So the relationship between Celsius and Kelvin is given by, you have here Kelvin, that is equal to degrees Celsius plus 273. So we can substitute the value for Kelvin there, that is absolute zero temp, that is 0 Kelvin, we have 0, that is equal to degrees Celsius plus 273. So degrees Celsius is equal to, we subtract 273 to both sides, we have here negative 273. So that is our final answer. So the temperature in degrees Celsius of absolute zero is negative 273 degrees Celsius. That is letter D. So let's proceed. How many degrees Celsius is 100 degrees Fahrenheit? So this is actually a ME board, April 1996. If you don't know the formula for this, you can derive it using the concept of the freezing and boiling point of water at standard pressure. So for degrees Celsius, we have 0 as the freezing point and 100 as the boiling point of water at standard pressure. So for degrees Fahrenheit, we have 32 as its freezing point, and we have 212 as the boiling point of water at standard pressure. So we can use ratio in proportion to find the relationship between this degrees Celsius and degrees Fahrenheit. So we have degrees Celsius minus, we have 0, all over we have 100 minus 0, that is equal to, we have degrees Fahrenheit, so 0 corresponds to 32. So we have all over, so 100, that is 212 minus, we have here 32. So we can simplify this. So degrees Celsius all over 100, that is equal to degrees Fahrenheit minus 32 all over. So this is 212 minus 32. This is 180. 80. We can further simplify degrees Celsius, that is equal to 100 all over 180 times the quantity, degrees Fahrenheit minus 32. So degrees Celsius, that is equal to, we have here the lowest term for this is, we have 5/9 times the quantity, degrees Fahrenheit minus 32. So there we have the formula. So this is the relationship between degrees Fahrenheit and degrees Celsius. So we can use this formula to solve this problem. We have degrees Celsius, that is 5/9 times the quantity of. So for degrees Fahrenheit, we have the given, that is 100 minus 32. So degrees Celsius is equal to, so you can use your calculator. So I am using this is Casio 570 ES Plus. So we can input this, so 5/9 times the quantity, that is 100 minus, so minus 32, that is equal to, so we have 37.8 degrees Celsius. So that is 37.8 degrees Celsius. So we have A as our answer. So we can also use our calculator technique to solve that. So there are two ways to solve this. So first, you can use the mode stat, and the second one is you can use the shift convert. So for the shift convert, you can press shift, that is shift, and convert, that is 8. And at the back of your calculator, the cover, you have there 37, that is degrees Fahrenheit to degrees Celsius. So you can automatically input it here. So that is 100 degrees Fahrenheit to degrees Celsius. You can press equals. Then you have here an answer. So we have the same answer, 37.8 degrees Celsius. And the other method is using the mode stat. You can press mode, so mode and stat, that is 3, and 2, that is linear equation. So we have here x. So for example, this column x corresponds to degrees Celsius, that is, so we have here 0. So for 0 degrees Celsius, we have, so the column y corresponds to your degrees Fahrenheit. So for 0 degrees Celsius, we have 32 degrees Fahrenheit. And for 100, you have 212 degrees Fahrenheit. So basically what we are going to do here is we are just using linear interpolation, but using the calculator technique. So since we have input the value, so these are the values. We have 0 degrees Celsius to 32 degrees Fahrenheit. You have 100 degrees Celsius, that is equal to 212 degrees Fahrenheit. So press off, this is off, then press shift stat, that is shift 1, then press 5, that is regression, then press 4 since we are going to find degrees Celsius, and x corresponds to your degrees Celsius, that is 4. So you can input the value for which you are going to derive Fahrenheit to Celsius. Let's say 100 Fahrenheit. So this expression means 100 degrees Fahrenheit is converted to x hat. So x hat means degrees Celsius. So 100 degrees Fahrenheit, how many is that in degrees Celsius? This is x hat. So you press equals, so you get the same answer. So there are three methods. The first method is, of course, using the manual method, using the formula. And the second method is using your mode stat, here mode stat, and the third method is using your shift convert there. So you can use the cover of your calculator. There are lots of conversions there. You can memorize those codes. So for the next problem, a comfortable room temperature is 72 degrees Fahrenheit. What is this temperature expressed in Kelvin? So first we have our degree Celsius and degrees Fahrenheit relationship. You have degree Celsius that is equal to 5/9 times the quantity degrees Fahrenheit minus 32. And we also have the relationship between Kelvin and degrees Celsius. So we don't have the direct relationship or the formula between degrees Fahrenheit and Kelvin. So we will solve first degrees Celsius and we proceed to Kelvin, that is degrees Celsius plus 273. So Kelvin, that is equal to, so we can substitute the value for degrees Celsius here. So we have 5/9 times the quantity degrees Fahrenheit minus 32. We have here plus 273. So this is their relationship between Kelvin and Fahrenheit. So we can substitute the value for this. So we have Kelvin that is equal to 5/9 times, so for degrees Fahrenheit you have given here 72 minus 32. You have plus 273. So get your calculator to compute this. So this is our scientific calculator. So input the value 5/9. So times, you have 72 minus 32. So this is plus 273. So you have here 295.2 Kelvin. So the nearest is, you have letter, so letter C as the nearest answer. So we have Kelvin, that is 295.2. So you have letter C as your final answer. So we can use also our calculator technique for this. So using shift convert, so that is shift. So you can press shift, so convert, so 8. We have 37, so that is degrees Fahrenheit to degrees Celsius. So you have here 72 degrees Fahrenheit, so that is degrees Celsius. Then you add 273 in order to convert that to Kelvin. So you get the same answer. And using your mode stat is mode stat 3, that is 2. So you have 0 for 0 degrees Celsius to 32 degrees Fahrenheit. You have 100 and 212 for degrees Fahrenheit. Press off. This is shift stat. So this 5 regression, that is 4, since you are going to find degrees Celsius. So that is 72. So this means that this is the degrees Celsius and you add 273 to make that Kelvin. So you have here answer as 295.2. At what temperature will the degrees Celsius and degrees Fahrenheit reading be equal? So you have this formula for converting Fahrenheit to degrees Celsius. So we have degrees Celsius is equal to 5/9 times the quantity degrees Fahrenheit minus 32. So it's stated in the problem that degrees Celsius and degrees Fahrenheit is equal. So we have degrees Celsius is equal to degrees Fahrenheit, and we can substitute that value to our first equation. We have degrees Fahrenheit is equal to 5/9 times the quantity degrees Fahrenheit minus 32. So we can cancel this 5/9 the other side by multiplying 9/5 to both sides, we have 9/5 degrees Fahrenheit is equal to degrees Fahrenheit minus 32. We can subtract degrees Fahrenheit to both sides. We have 9/5 degrees Fahrenheit minus degrees Fahrenheit is equal to negative 32. We have here 9/5 minus 1 times the quantity degrees Fahrenheit is equal to negative 32. So we divide 9/5 minus 1 to both sides. We have degrees Fahrenheit is equal to negative 32 all over 9/5 minus 1. So we can use our calculator. We can use our calculator to solve this. Negative 32 all over 9/5 minus 1. We have this, so we have negative 40 as our answer. So we have degrees Fahrenheit is equal to negative 40. So we have letter B as our answer. So we can also use our calculator technique to solve this. So we can use our shift solve function in order for us to minimize the time of solving this. We have here, as you can see here, we have one equation and one unknown, so we can find degrees Fahrenheit by using the shift solve function. So we have, let's say, the degrees Fahrenheit, let that be x. So we have alpha equals, so we input this equation, that is 5/9 times the quantity. We have alpha x, that is degrees Fahrenheit, minus 32. We can shift solve that, so we press shift and solve. That equals, so we have negative 40 as our answer. Now, the other calculator technique uses the shift solve function, and the other uses the mode stat function. So for shift convert, you have shift convert, so that is 37. So we will use trial and error to solve this. So let's say for letter A you have 40. So if that equals, so as you can see here, it is not equal to 40. So letter A is not the answer. So for letter B, we have negative 40. So as you can see here, negative 40 degrees Fahrenheit is also equal to negative 40 degrees Celsius. So it means that letter B, we are sure that letter B is our answer. So for the mode stat, you can also use mode stat, that is 3. We have 2, and at 0 degrees Celsius we have 32 degrees Fahrenheit, and at 100 degrees Celsius we have 212 degrees Fahrenheit. So we can use that. So let's press off, then press shift stat, then regression. You can use either 4 or 5. So let's choose 5. Say we choose 5, that is y hat. So meaning we are going to find the degrees Fahrenheit temperature given the degrees Celsius temperature. So let's try letter A. So letter A is 40. Say 40. So as you can see, at 40 degrees Celsius, that is 104 degrees Fahrenheit. So that is not equal. 40 is not equal to 104. So let's try negative 40. So we have here negative 40 degrees Celsius is actually equal to negative 40 degrees Fahrenheit. So letter B is the answer. What is the absolute temperature of the freezing point of water in Rankine? So you have the freezing point of water, that is equal to 0 degrees Celsius. So you have the relationship between degrees Celsius and degrees Fahrenheit, that is degrees Celsius is equal to 5/9 times degrees Fahrenheit minus 32. So we can substitute the value for degrees Celsius, that is 0 equals 5 nines times the quantity degrees Fahrenheit minus 32. So we can divide 5 nines to both sides. We have 0 equals degrees Fahrenheit minus 32. So we add 32 to both sides. We have degrees Fahrenheit that is equal to 32 degrees. We have Rankine that is equal to degrees Fahrenheit plus we have 460. So this is the relationship between Rankine and Fahrenheit. So we can substitute the value for Fahrenheit, that is we have Rankine degrees Fahrenheit is we have 32 plus 460. So you have Rankine that is equal to 492. So we have letter D as our answer. The angle of inclination of the road is 32 degrees. What is the angle of inclination in mils? So we have in the basis of 1 revolution, you have the conversion that is 360 degrees. In degrees, we have 2 pi for rad, this is degrees. This is radian. We have 400 grad, this is grad. And we have 6,400 mils. So we have this conversions. So we have 32 degrees times, you have 6,400 mils per 360 degrees. So we will cancel the unit of degrees. We have here mils, so that is equal to, we can use our calculator. We have 32 times, so we have 6,400 per 360. So we have 568.89. So we have B as our answer. So 1 nautical mile is equivalent to. So for miles we have 2 units. So we have here 1 statute mile and we have 1 nautical mile. So these units are actually different. Even though they are miles, they are both miles. So the other is statute and the other one is nautical. So when you say statute mile, that is equal to 5,280 feet. And when you say 1 nautical mile, that is approximately equal to 6,080 feet. So those are both different conversions. So for 1 nautical mile, so we can say that letter A is actually not the answer, because since it is 5,280 feet, this is actually a statute mile. So this is not the correct answer. So we have 1 nautical mile, that is 6,080 feet. So letter B, that is 6,280 feet. So therefore, it is not an answer. So let's try converting this nautical mile to kilometers. So for 1 nautical mile, we have 6,080 feet. So we have the conversion. We have 1 meter, that is 3.28 feet. We have this feet to meter. You have 6,080 divided by 3.28. 28. So that is 1853.66. You have 1853.66 meters. So we can convert this to kilometers. So we have 1853.66 meters times we have 1 kilometer per we have 1000 meters. So we have 1.85. So let's round this up. We have 1.854 kilometers. So we can also solve this using the conversions in our calculator. So if you look at the back of your calculator, you will see there for unit conversion we have 9, that is shift convert. You have shift convert, that is 9. That is nautical mile to meter. So let's try 1 nautical mile, that is 1852 meters. So divide that by 1000. That gives us 1.85 kilometers. So you can use shift convert function. Add the following and express in meters. So we have 3 meters plus 2 centimeters plus 70 millimeters. So this is actually an ME board, April 1994. Add the following and express in meters. So we have 3 meters plus 2 centimeters plus 70 millimeters. So this is actually an ME board, April 1994. So we have 3 meters plus 2 centimeters plus 70 millimeters. So the 3 meters is already converted, so we will convert the other two, which is 2 centimeters and 70 millimeters. You have 2 centimeters. You have the conversion, that is 1 meter per 100 centimeters. So we have 0.02 meter. So for 70 millimeter, we have 70 millimeters. We have the conversion, that is 1 centimeter per 10 millimeter. So the millimeter unit will cancel, and then for centimeter we have 1 meter per 100 centimeters. So that is 70 divided by, we have 10 times 100, that is 70 divided by 1000. So we have 0.07, that is meter. We have 3 meters plus 0.02 meter plus 0.07 meter. So we have 3.09 meters. So the answer is, we have letter D as our answer. How many square feet is 100 square meters? So this is actually an ME board, October 1994. So you have the conversion, 1 meter, that is equal to 3.28 feet. To convert this, we have 100, that is square meters. So we have the conversion here. So we have 1 meter per 3.28 feet. So since this is square, we will square this conversion. So we have 100 meters squared or square meter, you have 3.28 squared square feet per 1 square meter. So meter squared will cancel. We have square feet as our unit. So we have 100 times 3.28 square feet. So let's solve for that. You have 100 times 3.28 squared. So that gives us, we have 1075.84. That is letter C. So we have 100 square meter is equal to 1075.84 square feet. How many cubic feet is 100 gallons of water? So you have the conversion. You have 1 cubic feet, that is 7.48 gallons. So we have this conversion. We have 100 gallons. So the conversion is 1 cubic feet per 7.48 gallons. So we have this conversion. Gallon will cancel. We have cubic feet as our unit. So that is 100 divided by 7.48 cubic feet. That is equal to, we have 100 divided by 7.48. We have 13.37 cubic feet. So we have letter C as our answer. The acceleration due to gravity in English unit is equivalent to. So by definition, we have letter A as the answer. So in SI unit, we have G, that is acceleration due to gravity, is equal to 9.80665 meters per second squared. So you can verify that using your calculator. So using shift constant function, that is shift 7, that is constant. So you have 35, that is G. So the unit of that is meters per second squared. So we can convert this to feet per second squared. So you have 9.80665 meters per second squared times, we have 3.28 feet per 1 meter. So we have feet per second squared as the unit. So this is approximately equal to, you have 32.2 feet per second squared. What is the value in degrees of 1 radian? We have the conversion. So we have 2 pi, that is 360 degrees. So that is 1 revolution. So we have 1 radian. So we have 1 rad. We have 360 degrees per 2 pi rad. So we have 360 degrees divided by 2 pi. You have 360 divided by 2 pi. We have 57.3 degrees. So 1 rad or 1 radian, that is 57.3 degrees. A 7 kilogram mass is suspended in a rope. what is the tension in the rope in SI. So let's say this is the object. So the tension that supports the weight of the object. So this is the weight. You can say that summation of the forces along the Y for equilibrium that is equal to 0. So we have tension that is positive, that is upward. So we have tension that is positive, in the weight, since it is downward, it is negative. So minus weight equals 0. So the tension is just equal to the weight of the object. So we have the weight is equal to the tension, that is mass times the gravitational acceleration. So we have the mass there, that is 7 kilogram. Mass, that is, so for the acceleration we have standard, so we have 9.81, or we can use the exact value, 9.80665 meters per second squared. So that gives us, so we have the weight or the tension, we have the tension is equal to we have 7 times 9.80665. So that gives us 68.65 Newton. So that's 68.65, that is kilogram mass meter per second squared. The most important part in dealing with forces involving conversion is the gravitational constant. So we have the conversion 1 Newton, that's equal to 1 kilogram mass meters per second squared. And for English, we have pound force, we have 1 pound force, that is equal to 32.2 pound mass feet per second squared. So these two conversions are really important in dealing not only in forces but also in energy and power. We have the conversion, so we have 1 Newton per, so we have 1 kilogram mass meter per second squared. So this will cancel out. So we have Newton as our unit. So we have 68.65 Newton. So that is letter. So the nearest answer is letter. We have letter A. A 10-liter pail is full of water. Neglecting the weight of the pail, how heavy is its water content? So given the choices, we have kilograms. So we are asked to find the mass of the water in the pail. So we have mass. So we have the mass, that is the required value. The definition of density is the mass per unit of volume. We have the mass, that is density times volume. So the standard density of water, standard condition, so we have 1000 kilograms per cubic meter. We have 1000 kilograms per cubic meter. So we have given the volume, that is 10 liters. We have 10 liters. So by conversion, we have 1 cubic meter, that is 1000 liters. So this 1000 will cancel. So you have liters will cancel, so cubic meter will cancel, so you have 10 kilograms. So the mass is 10 kilogram mass. We have letter C is the answer. How many horsepower is 746 kilowatts? We have the conversion. We have 1 horsepower, that is 746 watts. So you have 746 kilowatts. So we have 1 kilowatt, we have 1000 watts. So we cancel kilowatt. So 1 horsepower, we have 746 watts. So 746 will cancel. So you have 1000 horsepower. So that is letter D. Calculate the weight in pound force of a 1 pound mass object in a gravitational field of 27.5 feet per second squared. So this will be the application of one of the most important part of conversion, that is the gravitational constant. We have the weight, that is mass, times we have gravity, or the acceleration due to gravity. We have the mass, that is 1 pound mass with the gravitational field of 27.5 feet per second squared. So that gives us 27.5 pound mass feet per second squared. So we're required to convert that unit into pound force. So as you can see here, that is pound mass feet per second squared. The only way to convert that is using the gravitational constant. We have the conversion. We have 1 pound force, that is equal to 32.2 mass feet per second squared. So we have here 27.5 pound mass feet per second squared. So times we have 1 pound force per 32.2 pound mass feet per second squared. So that is a very important conversion. So this unit will cancel out, pound mass will cancel, feet and second squared will cancel. So we have 1 pound force per 32.2 pound mass feet per second squared. So we have the weight, the unit of that is pound force. So we have letter B. If the density of a gas is 0.003 slugs per cubic feet, what is most nearly the specific weight of the gas? You have the conversion for slug. So 1 slug, it's a unit of mass. You have 1 slug, this is 32.2 pound mass. Converting this, so we have so the density is 0.003 slugs feet per slug per cubic feet. We have 32.2 pound mass per 1 slug. So slug will cancel, so we have pound mass per cubic feet. So 0.003 times 32.2. You have 0.0966. The density is 0.0966 pound mass per cubic feet. So we have the specific weight, that is density times the acceleration due to gravity. We have there the density. First we convert this to kilogram mass per cubic meter. We have the density 0.0966. We have pound mass per cubic feet. Converting pound mass to kilogram mass, so we have 1 kilogram mass. This is 2.2046 pound mass. We have cubic feet. We have 3.28 feet per 1 meter. So you raise that 3. You have 0.0966 times you have 3.28, so cube all over, so we have 2.2046. That gives us 1.546 kilogram mass per cubic meter. That is 1.546 kilogram mass per cubic meter. So the specific weight, that is density times the gravitational acceleration. We have 1.546 kilogram mass per cubic meter times the acceleration due to gravity, that is 9.80665 meters per second squared. You have there specific weight is equal to 1.546 you have times 9.80665. This is 15.16. We have 15 we have kilogram mass, we have meter per second squared per, we have cubic meter. So using the gravitational constant, so we have 1 Newton per, so we have 1 kilogram mass meter per second squared. So this will cancel. We have letter B as our answer. "100 milliliter of water in a plastic bag of negligible mass is to be catapulted upward with an initial acceleration of 20 meters per second squared. What initial force is necessary to do this?" So we have this diagram. So we have, let's say this is a plastic bag and we have water inside this bag. So in order to catapult this, we need to exert a force. So let's say this is force F, this upward. So the other forces acting on this plastic bag is, of course, we have the weight of the water inside the bag, And since this is moving, this is in motion, we have what we call the reverse effective force. So the body is moving upward, so therefore the reverse, since from the word reverse effective force, the reverse effective force is the reverse of its movement. So it's moving upward, so the reverse effective force is downward. So the reverse effective force is actually the kinetic reaction. So when you say kinetic reaction, according to the second law of motion of Newton, when a body is moving, the summation of forces along an axis is equal to the mass times acceleration. So that mass times acceleration is actually your kinetic reaction. And based on the Alambert's principle, the summation of those forces involving the reaction, kinetic reaction, is equal to 0. So let's say we have this axis, you have y as the vertical axis, so we have the horizontal axis as x. So we have summation of forces along the y that is equal to 0. We assume positive as upward. So we have reverse effective force that is downward, so it is negative. So that is REF. So we have the weight of the water in a plastic bag minus weight, so that is downward, negative. So we have force upward, that is positive, so equals to 0. That is what we call the D'Alembert's principle. So we have the force that is equal to REF plus we have the weight. So REF, that is mass times acceleration, and the weight, of course, that is mass times the acceleration due to gravity. So we can factor out mass times the quantity, acceleration plus the acceleration due to gravity. So that is our force. So the acceleration due to gravity is given, of course, that is 9.80665 meters per second squared. And the acceleration of the plastic bag is given. We have 20 meters per second squared. We don't have the mass, but we can solve it using the density of water. So we have the density, that is mass per unit of volume. The standard density of water, that is 1000 kilogram mass per cubic meter. So we have the mass, that is density times volume. We have the volume, that is 100 ml. We can convert that. We have 100 milliliters. So we have 1 liter, that is 1000 ml. Then we have 1 cubic meter, that is 1000 liters. So converting that to cubic meter, you have liter will cancel, we have ml. You have the volume, that is, you have 1 times you have 1 times 10 raised to negative 4 cubic meter. You have the mass, that is density 1000 kilograms per cubic meter times 1 times 10 raised to negative 4 cubic meter. So that is, solving for that gives 0.1 kilogram. We can substitute that here. We have the force, that is 0.1 kilogram. We have the acceleration 20 plus we have 9.80665, that is meters per second squared. We have the force. Solving for that is approximately 3 Newton. So Newton, because kilogram meter per second squared is just an equivalent unit for Newton. So we have this answer, letter B. That's it, guys. I hope you learned from this presentation. Continue to subscribe and see you on my next video.